All right. We're going to do half of the notes today and then the other half on Monday when we get back. You guys, you have a quiz next Wednesday over 8-1 and 8-2. 8-2 is about special right triangles as opposed to just regular right triangles. These guys are special because they're shortcuts to find side lengths. You don't have to use the Pythagorean theorem on the special right triangle to find their side lengths. Today we're going to go through one type of special right triangle, and then Monday we're going to go through the other special right triangle. Today's is the 45, 45, 90. Those represent the angle measures of the triangle. 90, 45, 45. The triangle has two equal angles. What else does it have? Two equal sides. So it's a right triangle, obviously, because there's a right angle there. But what do we call a triangle with two equal sides? Isosceles. So a 45, 45, 90 is also known as an isosceles right triangle. Okay, so I will say either of it. And it says that at the top too, I think, 45, 45, 90, and then it also says isosceles right. The other one that we'll do on Monday is called a 30, 60, 90 right triangle. So your angle measures on those are 30, 60, and 90. But we won't worry about them today. The shortcut, the 45, 45 theorem, says that in a 45, 45, 90 triangle, the legs are congruent, obviously, and the hypotenuse is the square root of 2 times the length of the leg. In shorthand, the hypotenuse equals the leg times the square root of 2. In a 45, 45, 90, the hypotenuse will always equal your side length, your leg, times the square root of 2. If I were you, I would circle that little rule or highlight that or star that or something. That's what you need to know today. Hypotenuse equals leg square root 2. Hypotenuse equals leg square root 2. And really all we're doing is taking the values that they give us, substituting them in either for leg or hypotenuse, and then solving for the unknown. So on our first example here, find the value of the variables. Use your 45, 45, 90 theorem to do so. Hypotenuse equals leg times the square root of 2. That's the rule you're using today. The more you write it down, the more you'll remember it. If I were you, I'd probably just write it down every time today, and then it'll get stuck in your head. So in my triangle here, 45 is congruent to 45. So if I have two equal angles, I should have two equal sides. Is it A and C, A and 5 square root 6, or 5 square root 6 and C? Yeah, A and 5 square root 6. Well, that makes finding A easy. A equals 5 square root 6. That's all you have to do on that one. Okay, then I have to find C. Is C representing a leg or a hypotenuse? Hypotenuse. So I'm going to substitute C in for my word hypotenuse there. Equals the length of the leg. Well, what's the length of our legs? 5 square root 6 times the square root of 2. Okay, the parts that are outside you can multiply together. The parts that are inside you can multiply together. So 6 and 2 are both under the radical. So 6 times 2 is what? Okay, so this becomes 5 square root 12. Can I break 12 down? What perfect square goes into 12? How many times? In the square root of 4? 5 times 2 times the square root of 3. 5 times 2 are both on the outside. So the length of our hypotenuse is 10 square root 3. No decimals unless it says you can round it. Same with your worksheet today. Put them in radical form. Alright, let's try 2. Find the length of the leg with a hypotenuse of length 22. So they're telling us it's a 45, 45, 90. So our rule for today, hypotenuse equals leg times the square root of 2. Take what you know and plug it in. They give me the value of 22. that representing the hypotenuse or the leg? The hypotenuse. With a hypotenuse of length 22. So we're going to substitute 22 in for the word hypotenuse. We're trying to find the leg, so I'm going to call that x times square root of 2. Got to get x by itself. I have to get rid of the square root of 2. How do I move the square root of 2 over? Divide, right? Because aren't they being multiplied on the right side? So we're going to divide by the square root of 2. They cancel on the right side. So we have 22 over the square root of 2. I don't want decimals unless it says so. But can I leave my answer like this as radical form? No, I can't leave a square root in the denominator, so we rationalize. Multiply by the square root of 2 in the numerator and the denominator. In the numerator, can we write that as the square root of 44? No. Can I write that as just 44? Can I write that as 22 square root 2? Yeah, that's how I have to write it. Because one's outside and one's inside. Denominator, can I write that as the square root of 4? I could, but I can keep going because the square root of 4 is what? 2. Now it's a fraction. They always have to be what? Simplify. The numbers that are on the outside, can you simplify 22 and 2? Yes. Yeah, how many times does 2 go into 22? 11. So then our leg length is 11 square root 2. Yes. Okay, try number 3. You have a square playground there or something? Some awesome person did the Pythagorean theorem a ton of times to isosceles right triangles, and they found this pattern, this shortcut rule that you can just take the length of the leg times the square root of 2, and it would always give you the hypotenuse. So that's where this is coming from. I should figure out who that cool person is, shouldn't I?
There was a guy in Rome who was playing bath tiles in a bathhouse.
Okay.
That's where teachers told us.
Oh, really? You did this last year?
Yeah. Not as in depth though.
Why'd you do this last year?
I don't know.
Okay.
Because Arizona. I didn't fail geometry though.
Yeah, that's what I was wondering last year.
I could be in that class though.
Is it because you didn't do your homework all the time?
Well, actually, I had an A, and then they switched teachers halfway through the year, and then my grade dropped from an A to an E. Ooh, she barely spoke English too. It would have been fun. Anyways, Mrs. Clara Lou did it.
You're right for that in college. All right, number 3. The distance from one corner to the opposite corner of our square playground is 96 feet to the nearest foot. How long is each side of our playground? When you draw that diagonal in there, you end up creating this isosceles right triangle. So 45, 45, 90. 96 is representing the hypotenuse, and m is representing my leg length. So when you start your equation, you should start it that way. To get m by itself, the side length of the square, I'm going to divide by the square root of 2, and I get m equals 96 over the square root of 2. How do they want our answer on number 3? Do they want the exact length or an approximated length? Approximated, which means you get to use what device? Your calculator. There is no need to rationalize this if you're going to end up using your calculator anyway. You can just throw in your calculator 96 divided by the square root of 2, and that will give you your rounded answer. Okay, so if it tells you round, you don't need to go through and rationalize or break down. What'd you get? 67.9. Okay, so now I have to be careful. To the nearest foot. Is that a decimal or is that a whole number? Whole number. So 67.8 to the nearest whole number would be 68. So it's about 68 feet on each side of the square. read carefully, 'cause then you are doing less work. You don't have to go through and rationalize this. You're gonna have to end up using your calculator in the end. If you do rationalize it, awesome, it's great practice. Kinda. Try it again. You should have different numbers on number 4. Go ahead and try number 4. Find the length of the hypotenuse of the 45, 45, 90 triangle if its legs are 5 square root 3. Forty-five, 45, 90. Top, the hypotenuse equals the leg times the square root of 2. Find the hypotenuse, so I'm going to put x in for that. If the legs are 5 square root 3. So there's your little starting equation there. Can I multiply any of those numbers together? Which ones? The 3 and 2, the 2 square roots, so it's 3 times 2. Can I break 6 down with perfect square? Alright, there's the length of your legs then. Excuse me, the length of your hypotenuse. Okay, uno más. A square garden has sides of 100 feet long. You want to build a brick path along the diagonal of the square. Okay, so back from chapter 6, we know that squares have 4 sides and 4 right angles, yes? Okay, I want to build a path here across my garden so I don't have to walk through the dirt or anything. I can walk along the path to go ahead and lead it. Each side of the garden is 100 feet, and we're trying to figure out how long this path is going to be. And I know how many tiles or bricks I need to buy so that I can create it. Well, when you throw the diagonal in there, your square becomes 2 right triangles that have 2 congruent sides and an isosceles right triangle. So now we have a 45, 45, 90. On my 45, 45, 90 right here, is my x representing the hypotenuse or the leg? Hypotenuse. So our rule, hypotenuse equals the leg times the square root of 2. That would be the exact length that you would need, but that's not really going to help you when you go to Menards to buy the supplies to make your path. You're going to want to round this, and this one says round to the nearest foot. Is that whole number or decimal? Whole number. So then in your calculator, take 100 times the square root of 2 and round it to the nearest whole number. 141 feet.
But if it's for construction, shouldn't you round it up so you don't end up with too little?
Probably, but we'll just follow these directions. Good thought, though. All right. Questions on your 45, 45s? It's not too terribly rough, is it? No. All right. As long as you know your rule, you should be all right. That's all we have for notes today.